Hello, everyone, and welcome to today's SANS webcast, a SANS 2021 survey, Vulnerability Management, Impacts on Cloud and the Remote Workforce, sponsored by Arctic Wolf, Automox, BlackBerry, Cisco Umbrella, ExtraHop, Gigamon, Rapid7, and Vulcan Cyber. My name is Jennifer Lynn of SANS, and I will be moderating today's webcast. Today's featured speaker is David Hazar, SANS course author and SANS analyst. If during the webcast you have any questions for our presenter, please enter them into the Q&A window at any time. Please note that this webcast is being recorded and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to David.
All right, thanks, Jennifer, and welcome everyone. It's great to be here today to discuss the results of our 2021 survey. A bit about me before we get started. I've been working in technology for over 20 years, and I have a bit of a diverse background that includes some development and engineering work, but over the last 10 to 12 years, I've been heavily focused in the areas of vulnerability management and application security. More recently, I've done a lot of work also in cloud security and secure DevOps as those areas have grown and there's been a greater need there. For SANS, I teach Sec 540, which is their cloud security and DevOps automation course. And I also teach Management 516, which is a class I co-authored with Jonathan Risto that we called Managing Security Vulnerabilities, Enterprise and Cloud. Today, we're going to take a look at the state of vulnerability management before we dive into the survey and the different statistics and data points on organization maturity that we gathered this year. I'll provide some commentary and recommendations throughout, but I'm also going to summarize some of those recommendations at the end to make sure that I don't forget anything. And towards the end, we'll also have some time for questions. And so make sure that you get those into the question and answer pane, and then we'll respond to those at the end. So the state of vulnerability management hasn't changed much in the past couple of years. So if you watched this webinar last year for our 2020 survey results, this list is pretty much the same. And that's not very surprising to me. Improving anything security related and especially vulnerability management is like turning a battleship, right? It's this huge effort. And we've been working on it for a long time. It's one of the oldest security functions, but we still see massive backlogs for most organizations. And I think we're forced sometimes into focusing too much on identification, because as security professionals, that's an area where we have the most control and ability to execute. And so that's another problem that I see. Another area of focus throughout the industry has been on prioritization. And while I won't argue that it's not important, it is very important, there are some obstacles that get in our way to making that more effective. And these obstacles lead to exceptions, which may not be communicated properly or get the visibility they deserve. And many times standard reporting and analysis capabilities in our tooling may make that effective communication difficult. Certain asset types consume too much of our time and generate huge amounts of false positives. If you've ever run a static application security testing tool, you know what I'm talking about. And I don't care which vendor, I've yet to encounter one that doesn't have this problem to some extent. Our environments are also constantly changing and growing. We might think that we'll just shift everything into the cloud and that'll make things easier or less expensive. And then a short time later, we find that, hey, somebody found out that with a click of a few buttons, they can have high availability, or they can add resources in other regions to get more global distribution. And quickly things multiply and we have more and more things to manage. Now, the one saving grace in all of this is that some of these new technologies and operating models also provide opportunities to do things better or different than we have in the past. So it's not all bad. Let's talk about how things are changing and some of the good and the bad that come along with that. So how is VM evolving? On the good side, containers and other programmable architectures can lead to better management of our configurations and software dependencies. When we define things in code and replace them instead of upgrading them, it can be easier to keep things up to date and therefore a little bit more secure. If we build those design principles into the existing workflow, that's where we can see the biggest gains here. If we can ensure that as part of that regular workflow, things are getting replaced with an image or a configuration that is up to date or has the latest configuration standards baked into it. The shared responsibility model in the cloud allows us to shift a lot of our responsibility for traditional vulnerability management functions like patch and configuration management to our cloud vendors. And if we can offload a lot of that to maybe moving our workloads from infrastructure as a service and on premises to platform and software as a service, this can help reduce our vulnerability management burden, which will allow us to focus on and spend more time on the workloads that maybe for whatever reason, it could be due to criticality or visibility that we need to have, are still on premises or in those infrastructure as a service offerings in the cloud. And so by moving as much as possible over to platform and software as a service, we don't have to deal with those operating system vulnerabilities and configurations because the vendor is taking care of those for us. More iterative styles of development are also great because they allow us to change more frequently in our environments. And this can help reduce our exposure windows, how long between a vulnerability is released or an asset is introduced, a vulnerable asset is introduced into our environment until we have those problems fixed or remediated. We also have better and less expensive or even free tooling to accomplish many of the tasks that we have to perform within vulnerability management and to help with automation. In general, I think most organizations have now bought into the importance of security and are providing investment into our programs as well. So that's a struggle that we had in the past that due to increased threats and into things that are happening with other organizations, we don't have to do as much selling as we have in the past. I'm not saying that we don't have to sell at all, but maybe it's not quite as hard as it has been previously. While there's a lot of good, we're still left with some bad. With virtualization, cloud, and containers, our workloads are getting smaller, but there's more of them. Like I mentioned earlier, many organizations misinterpret or fail to dig into the shared responsibility model deep enough and truly understand who is responsible. And that can lead to gaps in our security. If we think the cloud vendor is taking care of something and they're not, then we have a gap. And so we need to be careful there. We need to really dig in and talk to our vendors about what they're responsible for and what we're responsible for so that we don't have those gaps. Traditional vulnerability scanning is becoming less effective. In our cloud and container environments, the rate of change makes our traditional tools harder to manage. Network-based scanning is becoming less relevant, and we're starting to shift to agents more because of cloud, but also because of the remote workforce. Cloud vendors seem to prefer agents, which makes sense. There's less discovery traffic and things like that on their network. But also, as we've had to shift to a more remote workforce recently, it's made a lot more sense to use agents. As we switch from IPv4 to IPv6, agents might make more sense as well, because it's harder to do that discovery in that large address space. And then with cloud and containers, we've shifted some of our identification over to image scanning instead of having to do scanning on all of our resources, and we'll talk more about that later. While we may be shortening our exposure windows, at the same time, attackers are shortening the mean time to exploit for known vulnerabilities. So there's a problem there. Like, we're reducing the amount of time we're exposed, but the attackers continue to be able to quickly develop or more quickly develop exploits for vulnerabilities as they're released. So we need to make sure that we're active and responsive in patching those vulnerabilities as we see them in our environment. And that's something that I know many are still struggling with. And then there's the fact that we are all busy, especially our development and engineering teams that are always, they always have a backlog of things to do. It's never like, oh, we have nothing to do today, let's work on security. It's always, what features can we put off or delay so that we can resolve some of these security issues that have been hanging out for a while. In the survey this year, we looked at whether or not organizations had a program or certain program components in place. We also looked at how roles and responsibilities were divided amongst the various departments and whether or not automation was used across various asset types. And this is similar to previous years, but this year we also added a maturity component to the survey based on the SANS vulnerability management maturity model, which we put together to help program managers and other stakeholders gauge the maturity of their programs. As Jonathan and I taught Management 516, we would frequently have students ask, well, how do we measure our maturity? And then once we came out with the maturity model, it's like, how do we understand where we're at in relation to the industry or our peers? And so that's why we wanted to add that into the survey this year, so that you have some data to use to see, okay, where is it that we're maybe a little bit behind other companies in this space, or where are people struggling the most in vulnerability management, and where do we need to make the most gains? As with the past couple of years, the majority of our respondents came from organizations that were headquartered in North America, but that was followed by Europe and Asia. And then although 81% of respondents have operations in the United States, there is still a global presence. 1/3 of the respondents have operations in Canada, Europe, and Asia. A quarter of respondents in Australia and Latin or South America. The industries shifted a little bit from previous years, with government and technology organizations edging out respondents from financial services for the top spots. And that was followed by cybersecurity, education, healthcare, manufacturing, and retail. Small and mid-sized businesses were made up a greater percentage of our participants this year than previous years, but companies with more than 10,000 employees accounted for 31% of the participants. So we had a lot of very large organizations respond. And then even though participations from companies with smaller sizes in terms of people made up the majority, 53% of companies had revenue over 250 million. So they may have been smaller in terms of people, but larger in terms of revenue. And I think we see that a lot in some of the technology organizations where they don't have retail employees and other employees spread across a lot of physical locations, but they are generating a lot of revenue. To go through some of our statistics, we first asked if the respondents' organizations had a vulnerability management program. Over 92% said yes, which is up from the last 2 years. It continues to grow. The rest said they planned to in the next 12 months. And this is the first year that 0 respondents said no, right? Like, we don't have any plans for a program at all. We don't have one now, and we're not going to have one in the future. It'll be interesting to see if we can get to 100% next year, if all of those respondents get their programs implemented and we don't have any new ones. The breakdown by organization size was pretty consistent as well, but as expected, the number of organizations with formal programs tends to trend a little bit higher for larger companies. In terms of the asset types we cover within our program, on-premises traditional infrastructure still takes the top spot, but cloud and other categories are growing. It's also nice to see that many organizations are leveraging asset inventories, threat intelligence, ticketing systems to help provide context for prioritization, and also to help track the work that's being done so that our program participants get credit for completing their tasks, right? The remediation team members, the people that are actually doing the work to fix the vulnerabilities, we want to make sure that they are measured on their performance and they get credit for that work, so that their managers don't see their, if you're a developer and your velocity starts going down because you're working on security issues, that's not a great thing. I think giving credit is very important. I think that it's going to help those teams continue to engage with security, and so we need to spend some time with HR and with other teams figuring out what that looks like for our organization. For those team members, security is a priority, but it might not be a primary responsibility. While information security is still the largest player in the VM in the VM program management, governance, and discovery areas, I do see some organizations who are deciding to leverage their IT teams for those functions. And that could be because they don't have a dedicated security department, or it might be because it allows them to streamline certain program elements or tasks. And one example I can give is setting up and managing credentialed scanning. That's a task that might be more difficult for security to manage because they don't always have visibility into when and how credentials are being changed. So instead of having security gather those changed credentials from IT on some regular basis, or when they see failures, and update those scan profiles, it might be easier for IT to get involved in that process. Having IT responsible for more VM activities could also lead to higher levels of automation and faster resolution to any misconfigurations. Now, I'm not saying we should cede responsibility to IT for all operational and engineering tasks, because we already know they have too much to do, but in certain circumstances, it might make sense. If that's an area where we're struggling, or if our IT teams mistrust our tools and don't think that they're managed well, then by moving that over into IT and becoming more of a governance overlay on top of that, making sure that they are still setting up and scanning the things that they should be, we might be able to alleviate some of those complaints. If we look at where we're doing automated vulnerability discovery, on-premises traditional infrastructure leads by a large margin. However, if we look at the year-over-year change, that's the asset type with the lowest growth. And I wouldn't be surprised to see that number drop in the coming years as cloud and container environments continue to grow. In the environment that I'm engaged with right now, it's very, very few infrastructure as a service or virtual machines, very little on-premise footprint. Most of it is containerized or platform as a service. From the business partner side, I see that more companies are asking permission to scan their business partner applications directly and infrastructure directly, but most still rely on provided metrics or attestations from third parties to make sure their business partners are managing their risk appropriately. It is important to note, though, on these selections that they weren't exclusive. And so there are companies that are asking for the information, but then still doing some scanning to validate what was provided to them from their business partners, or maybe for certain critical assets, they're wanting to do their own scans. And so that's an area where, we have our own stuff to deal with, but we still want to get some visibility into what our business partners are doing, because they could increase the risk that, or at least they could be an area of risk that's unknown or that we're unaware of. And so we want to get some visibility into that. Before we dive into the maturity scores for the different functions, I wanted to talk briefly about the PACT model. So PACT is the acronym that we use in management 516 to highlight the different phases of the VM life cycle. And those are prepare, identify, analyze, communicate, and treat. And these phases are just meant to remind us that successful vulnerability management involves more than just running scans and tests to identify vulnerabilities. We need to make sure that we understand the data, we communicate that effectively, we fix the problems, and then we iteratively improve. And by doing this, we can get the help, support, and buy-in we need to make further improvements or remove any of the major obstacles or impediments that we have in our environment. The way we set up our maturity model was to identify 2 or 3 primary functions within each of these phases, and then come up with maturity descriptions for those functions that allow organizations to rate themselves on a maturity scale with 5 levels. In our survey this year, we asked respondents to identify which level best described their organization for each of those functions. So let's take a look at some of these functions. For the first one within the prepare phase, we have policies and standards. Now, personally, creating and maintaining policies and standards is not my cup of tea, but I do have some former colleagues that absolutely love it. So I gladly let them take control of that area. Policies and standards are important though, because they help provide direction and set expectations for our employees. They also can influence what is required from us when we have auditors and other third parties that are interested in what we're doing for security. Now, for some of us, this is much more important than others. Some of us are in highly regulated environments. We might have certain compliance standards that we have to have baked into our policies and standards, our processes and procedures. But I encourage you to set realistic and achievable policies and standards, because these are our requirements. These are the requirements that we're going to be held to when those auditors come to investigate. We need to make sure that we have the evidence we need so that we can demonstrate compliance. Now, we may make our standards too achievable, and it's possible that we're living with too much risk, or that the auditors are not satisfied with what we're doing, or the third parties, our business partners, and we might need to up our game, but that's okay. That's pretty typical. It's not abnormal for us to have some action items that we need to work on, and we can incrementally add in some of these new requirements as stretch goals for our organization that will help us reduce that risk. Once we've defined and communicated these standards that we've created, we should look for opportunities to automate compliance. While this isn't easy and can be a huge lift initially, it'll pay dividends for years to come. And also, the opportunities we have for automation these days are much more than we have had in the past. And especially since a lot of our environments are now software defined. So we can bake in these requirements to the code and scripts that we're using to build out that software defined environment. And then we can also leverage some of the automated compliance checking technologies that are out there to make sure that we did it correctly. We also have a lot of organizations that are moving towards DevOps, and we can build many of our controls and the generation of our artifacts and evidence into the DevOps pipelines that we have. If we maybe aren't as mature in the automation space, there's also no code and low code capabilities built into a lot of our service and operations management tools. And so if we can't get the DevOps team members time and we don't have those automation capabilities in our department or in our team, then maybe we can leverage some of these other options to automate certain repeatable tasks. I'm not surprised to see that many organizations are still not quite satisfied with their asset inventory. Keeping those repositories up to date and leveraging them effectively can be super difficult. But since most of our infrastructure these days is virtual or programmable infrastructure, there's a huge opportunity to improve in this area over the next few years. We just need to get better at leveraging the cloud virtualization and orchestration APIs that we have to help us gather the basic details on what exists in our environment. And then there's a little bit harder task of finding the best way to supplement that data and add and store additional context. There's the detail of the system or the application itself, but then there's the context that we need in terms of ownership and who's responsible for certain types of vulnerabilities on these assets. What are the criticality levels so that we can build that into our prioritization. And this is where tagging or labeling can play a role. Those are capabilities that are almost universal now. If we don't have them anywhere else, which we're going to, but if we don't have them anywhere else, a lot of our vulnerability discovery tools do have the tagging capabilities. And so we may be able to leverage tags or labels in a variety of our systems to help us store and manage that context. If we don't have an enterprise asset inventory tool that's able to keep track of these assets. Infrastructure and applications seem to be the easiest asset types for most organizations to scan for vulnerabilities using automated tooling. However, when you look at level 5, cloud has a little bit of a stronger showing there. And I think that's because there are so many capabilities in the cloud that make automation easier, to make automated discovery easier. A lot of the cloud vulnerability management, cloud security, cloud compliance tools, whatever you want to call them, just need API keys to do their job. You give them an API key and they can go find all of the little misconfigurations within your systems. I am a little surprised that containers don't rank a little bit higher. There's so many free or low cost options for container scanning these days. I know where I'm currently engaged, we have like 3 different options for container scanning within our tooling. And all the major cloud providers have integrations to make this easy. If you're storing your container images in a cloud repository, which is almost a requirement if you're using the cloud, then you have the capability to either for free or for a small incremental cost do that scanning. And then if you don't have it in the cloud, there's typically other security packages that you have that include that functionality. Maybe it's just a function of organizations needing to take the time to write down and codify those processes. They're new, maybe they haven't had a chance to figure out how to do that in a standard way. Maybe we're still evaluating different technologies to figure out what works best, or maybe how to report on the findings. Maybe we're doing the scanning, but we're not comfortable saying that we're more mature in that area because we're still working on the best way to communicate those findings. Manual assessment is still an important part of the VM program. It's very important if we don't have the automated tooling, but even once we get the automated tooling in place for our infrastructure and applications, we might still need help quantifying the risk to get the buy-in to fix some of these hard to fix issues. And that's one area where manual testing can help us out. But another reason that we do manual testing is that there's certain types of vulnerabilities, especially at the application layer, that automated tools don't currently do a good job of identifying. Business logic flaws, authentication and authorization bypass flaws. Those are difficult for most automated tools to identify because they can't easily and automatically determine intent. not only the intent of the user, but also the intent of the application. Was I supposed to go from screen A to screen B to screen C and screen D? Or is it okay that I go from screen A to screen D? They don't know how our applications are supposed to behave and who's supposed to have access to what functionality. And so they can't always identify when the application is not performing as expected. That's why we still do manual testing. Now, there's some newer automated technologies that do get into behavior analysis, but I find there aren't near as many organizations leveraging those technologies. And I doubt they'll completely replace human analysis anytime soon. They may help us reduce risk, though, enough to maybe lengthen the time between our manual assessments so we don't have to spend as much time or effort there as we have in the past. Crowdsourced identification and security researchers can provide if we leverage those appropriately. I think the most important part of this external identification is to make sure that we have a vulnerability disclosure policy that allows us to set the scope and expectations for anyone that's testing our application without us formally setting up an engagement. So because like even if we don't have a bug bounty program, there are going to be security researchers out there that do testing against our services, even if it's against our terms of service. When I worked with a large technology organization, it was against their terms of service for customers to test their applications, but it happened all the time. We need to make sure that everyone understands what's allowed and what's prohibited, because there might be certain portions of our application that we don't own and that can't be tested. So we need to set those expectations, but also those that are doing this research or doing this testing to help us find our vulnerabilities, they need to know what to expect in terms of what happens when I report a vulnerability, or where do I report a vulnerability? How long does it take for us to get some sort of response? Should they even plan for a response? The technology organization I mentioned, they chose not to respond for whatever reason when vulnerabilities were discovered in their systems, probably because it was against their terms of service anyway. Do we pay for bounties? Do we offer bounties for our findings? And having answers to these questions available helps, right? It helps them understand what is expected and to not get frustrated. We don't want to have a situation where it leads to some sort of public disclosure of a vulnerability that we haven't had a chance to fix yet because it was sent to some random employee and they got the report and didn't know what to do with it or sent it to the wrong person. And that's why even if we don't have a formal bug bounty program, we need to have something in place here. There's not much I can say about prioritization that hasn't already been said. I think this is one area where we've seen a lot of thoughtware and technology over the years come out to help us do a better job prioritizing our vulnerabilities. And we see that most organizations are doing some form of prioritization. We're improving that over time by layering in additional metrics like asset criticality and threat intelligence. But what I'd like to do is move on to root cause analysis, and then we can talk about how those two functions might be somewhat related. I think root cause analysis is at times overlooked in our VM programs when the responsibilities are split between security, various IT groups, and the business. That complexity can make it more difficult to see the problems we're facing. Security might think that IT isn't patching or developers aren't fixing code insecurities because they're oversubscribed or lazy, when in actuality, it may be because the reports are incorrect. The vulnerabilities might be assigned to the wrong team, or there might be certain business requirements that prevent us from patching or fixing those vulnerabilities. Also, I think that sometimes security and IT both are aware of and acknowledge that a certain problem is too hard for them to fix on their own, but they don't properly highlight or quantify the risk to the organization. And this is where creating more meaningful groupings of our vulnerability data can help. If we have a report of maybe the top 10 most common vulnerabilities, that's a common report that we see, that might be interesting, but what might be more interesting is to identify the most common software packages with critical or high vulnerabilities, or maybe the most common software packages with patchable vulnerabilities. These should be vulnerabilities that are easy to fix. We have a great patch management program. Why aren't they being fixed? Looking at the data from various groupings helps us more easily drill down to that root cause, or at least start conversations that lead to those discoveries. And so I've developed these reports in the past where 92% of the vulnerabilities were made up of update Java, update Windows, and update Red Hat. Well, it didn't take that long talking to the different IT teams to figure out why they were having problems patching Java, why they were having issues with Windows and Red Hat. And so then we can take action to change things so that we can move forward. We need to have those conversations. Maybe it's because an older version of that software package is required. Maybe it's because the software that software update wasn't approved because we did some testing and there was some sort of availability concern. And once we understand the root cause, we can make a decision and either fix it, remove the roadblock, or determine, hey, this really can't be fixed, and we're going to need additional budget or additional resources that our program doesn't have. I've historically found that over 50% and usually closer to 80% of an organization's outstanding vulnerability backlogs are made up of issues like these, where we need additional help or additional resources in order to make drastic changes in our organization to get these fixed. And if that's the case, you can prioritize all you want. If you don't somehow compartmentalize those 50 to 80% of vulnerabilities that can't be fixed, the fixable vulnerabilities, the ones that we can fix, are just going to get lost in the noise. And so what I recommend is let's remove those unfixable vulnerabilities from our operational reports so that those teams that are fixing vulnerabilities can focus on what's achievable. And then we can highlight the issues that we've set aside on our program level and executive reports and dashboards, where they're likely to get the visibility and the support that we need to actually make the changes that we need to make in order to get to those vulnerabilities as well. Because we can't ignore those. That's our technical debt. They definitely still are risk to the organization, and we have to fix those, but it might take a project, it might take months or even years to figure out how to change architecture and design to allow us to finally remediate those. And I talked about reporting a bit, but in our metrics and reporting, this is another area where organizations are struggling. As we just discussed, it can help us with our root cause analysis. In large part, I think the struggle here stems from the fact that many of the out-of-the-box reports and metrics in our VM tools are more valuable at the program level than at the operational level. So at the operational level, we're stuck with either detailed output for the entire organization that our stakeholders have to comb through. Maybe we take the time to filter reports and send out emails and distribute those to the right people to make it more relevant. But that's cumbersome, it takes time. And so there's a longer delay before they get access to those vulnerabilities. And the other problem is that we don't always have enough context within those tools to create the custom reports that we want to generate to make those reports and metrics more valuable. Maybe we can get that context into tags, but what do our tags allow us to do within our VM tool? Can we create grouped dashboards and charts based on those tags, or are we just stuck with only being able to filter on those tags, which is what I frequently see, is like it's not available for us to build out or customize our reports. We can do some filtering, and then we're left with coming up with scripts that email out reports based on the filters with these tags included. And it's just not quite as elegant as if we were able to get that into a more enterprise reporting solution. And this is where engaging with our business intelligence teams can really make a difference. They may already have access to data sets that we want to leverage: our asset inventory, ownership information, criticality information. Even if we don't have it on every individual asset, if those assets are related to higher level business services, and we can inherit the criticality from there. If somewhere we've defined recovery time or recovery point objectives, we can get some criticality information, or we can derive some criticality information based off of that information. That might be in our data warehouse already. So if we can get our vulnerability data into that same warehouse or a similar warehouse, and then leverage the business intelligence team to build out some dashboards and reports, that gives us better reporting, better grouping, maybe some drill down capability that we didn't have. And the other thing that it does is it gets the data into a place that it's more likely that our stakeholders are coming to the dashboards and reports that our business intelligence team is creating than coming to our security tools to look at reports. There's going to be less effort involved in getting people to interact with that data if it's in their dashboards and reports that they're already viewing, than if we have to influence them to come to ours. And that's going to lead to a lot more engagement. And I'll tell you, it's not always positive engagement at first. Well, this data is wrong, it's horrible. What are you guys doing? You don't seem to have this configured right at all. But I'll take negative engagement over no engagement any day. Negative engagement I can fix. I can fix that report to be correct, and I can explain why it was incorrect. But if you don't even care and you're not engaged, that's, to me, a much harder problem to solve. Alerts can definitely help with the most critical vulnerabilities and can aid in accelerating response if we use them sparingly. But it's a fine balance. What's enough alerts to generate action, but not too many? We don't want people writing rules to move alerts to a separate folder in their mailbox, because then they just won't ever look at that folder anymore. And so what's just enough? And that's a fine line to figure out where it should be and the quantity there. In general, I think we're doing a little bit better here than in our reporting and metrics areas. And that's just because it's a subset of our data that we're wanting to alert on. And so we can put a little bit more focus there in getting it right. But I think we can always improve, right? We can always do things a little bit better. For change management, again, we see that our more traditional asset types like infrastructure and applications are more mature. And these are the asset types that existed when ITIL came out. So that kind of makes sense. But I think many organizations are struggling to find the best fit for container and cloud environments in their existing ITIL practices. I think the focus here needs to be figuring out how to make many of our smaller, low-risk changes that are much more common these days standard changes, so that they don't have to go through the more rigorous normal change process. And I would hope that patching and configuration management processes, small bug fixes in our code would also qualify, as long as we have well-defined processes that reduce risk as much as possible and maybe we've tested our ability to respond and recover when things don't work out as expected. If we can get our mean time to recovery down to minutes instead of hours or days, like it has been in the past, then I think that these organizations will be much more willing to move us into the standard change bucket. Now, patch management seems easy, and I'm not surprised to see the maturity here a little bit higher, because we typically do have well-defined processes for this within our organization or within the organizations that I've reviewed. But the reality is that most of the vulnerabilities on our backlog on the infrastructure side are patchable vulnerabilities. That's almost always the case. And this is why what I was talking about before, root cause analysis, is so important. Because even though our process is mature, it can't account for every deviation and may not even account for the common ones. If there's a vulnerability that's not getting patched, why? Well, is the patch management agent installed on the assets with that vulnerability? Okay, if that's true, is the agent reporting back to the console? If that's true, then is the asset part of some exclusion group where that asset's not being patched for whatever reason? If that's not true, is the patch part of an exclusion? We've realized that this patch causes issues, so we've excluded it. If that's not true, does the asset have low disk space? If we can identify the patterns that, as we do the root cause analysis, this is a pretty common pattern that we see when patchable vulnerabilities are not remediated, then we can start to come up with solutions and then hopefully build out playbooks or even automate some of that analysis or resolution in the future. Certain configurations are easy to remediate. You just change the setting, it very rarely affects things. Others are very hard. And so I think that testing is a very important part within this process. We need to make sure that the configuration changes that we make are not going to have impact. And that's true for patches, although patches have become better over time, where there's much lower failure rates. But when we change our configurations, we need to make sure that we're testing those. When we make changes to our code, we test those, because we could get it wrong. Now, I'm a little surprised that cloud and containers are less mature here. And I think that's going to change in the future. And those, those numbers will increase in terms of maturity, because it's defined in code, right? Our container is defined inside of a Docker file. A lot of our cloud environments are defined in Terraform or CloudFormation or Azure Resource Manager, Google Cloud Deployment Manager. We could be using one of the SDK-based solutions as well. There are a variety of ways that we can define the configurations for the assets that we're creating in those environments and keep them up to date. And then also, it's much more likely that we're just replacing assets. And so as long as our application can deploy to this new asset and it doesn't cause issues, and we can test that in our pipeline, then we can make sure that our containers and cloud resources that are following more of an immutable design are both patched, but also configured securely. And so that's an area where I think if we put some focus there, we would be better prepared for the future as we shift more away from on-premises to these other types of operating models, traditional on-premises, I guess I should say. Now, we clearly still are figuring out the best way to leverage and assess our cloud environments. Even though the capabilities are there, we still have some work to do to leverage those capabilities holistically, and also to define our processes so that we can maybe measure ourselves better. And I think that another important thing with the cloud is to not get trapped by the architecture and design of the past. Even though with infrastructure as a service, we can do things in a similar way to what we have done in the past, that doesn't mean it's the best options. Agents are more effective in the cloud. We don't have to worry about security groups and NACLs and all of these other things that might prevent access, peering relationships, where to put our scan engines, how many scan engines, where to put the console. If it's still on premise, how do we get VPN access back to it? If we have an agent, we have one connection, the agent to the management console. That's what we have to worry about. If we have more of an immutable design, if we're replacing things and instead of changing them, then why not just scan the image if we're containers or a representative instance? I mean, why would we scan 500 Kubernetes nodes when we know they all use the same base image, the same configuration, and they're replaced at least every 2 weeks? Now, maybe we do that because the out-of-the-box reports don't allow us to highlight that those critical vulnerabilities exist on not just one image, but 500 instances that were created from that image. But I still think it's a waste of time and resources to do assessment of all of these instances that are identical, that we know are identical. We need to find some better way. And at least on the container side, there are technologies that are starting to report on image usage along with the image scan results that they're providing. And so I think that if we can find some way to do that on our own or through these technologies, that can be helpful. And so to summarize, we need to spend more time digging into the data to discover what it tells us about our struggles. And this is going to help us craft our story or stories for our different stakeholder groups and senior management, so we can get the help and support that we need to fix things. We can't expect to solve this problem overnight. We've been struggling with it for a really long time. And with the pace of change in technology, we need to be realistic about what we can accomplish, and then also be light on our feet because things are going to change. And this is why I recommend we focus on small, steady gains. If we try to focus on everything at once, or maybe try to put in place a 2 to 3 year roadmap, it's not a bad thing to do, but we might struggle to make gains because we are split. We have so many things to look at and focus on, or we have to constantly explain why our roadmap keeps changing. If we can remain more agile and have a backlog of things that we need to accomplish, and then just start to accomplish a little bit at a time, then we at least are ensured that we're making forward progress. If we can just find a problem, fix another problem. We should also be actively engaged with our architecture and design teams so that we understand what's coming and can discuss how VM fits. And by doing that, we can possibly avoid this, hey, let's bolt on our VM process after the fact. And maybe that forces us to use a more traditional model because we don't understand how to integrate into these new workflows, these new environments. If we take the time to understand that up front, we can avoid some of the mistakes we've made in the past. We can add more consistency, better visibility. And another thing to remember is there's never one solution to any problem. So don't be afraid to brainstorm ideas with your stakeholders. Chances are you've got a lot of smart people in your organization, and if you can clearly highlight the risks or the problems, they might be able to help you come up with an even better solution than the one that was reported by whatever tool or test report you got. And so leverage those people closest to the issue to help you with that. So I'd like to thank everyone for attending today. We'll take a look at some of the questions that you've posted If you do have any questions, please put them in the Q&A window. And let me see what we've got here. All right. So the top 5 vulnerability management tools, that's a tough one because there are so many different types these days. And so if we're talking traditional infrastructure scanning vendors or tools, the top by usage, at least that I've seen throughout my career, are going to be, Tenable, Qualys, Rapid7 in no particular order. You've also got some other vendors out there that are focused more on like passive discovery or specialized types of discovery. So Skybox Security does some more passive, it's more of a reporting, I guess, and it gets vulnerability data from other tools. You've got Zingbox is one that's a passive tool that focuses on IoT and doing passive discovery for those types of environments, maybe SCADA networks as well. There's others that are out there. There's the OpenVAS, which is the free offering, but that it's only free for the version that doesn't have the signatures that are updated. So you've got to go to their paid offering to get something more than that. You've also got in your cloud environment, you've got integrations in Azure with Qualys. So as part of Azure Defender, you get the Qualys agent. And then on AWS, they've decided to build their own agent. So if you're in the cloud, you've got Inspector. Now that's the infrastructure side. When you talk container scanning, it depends on whether you want to go with commercial, and all of the ones that I mentioned on the infrastructure side that are the top ones for infrastructure, traditional infrastructure scanning, they'll also have a container security component. But if you're looking at more of the open source offerings, I think the most popular ones are going to be Encore, ClareOS, and Trivy. And again, not in no particular order. You've also got the container scanning within the container security tools like Palo Alto Prisma Cloud, which was formerly Twistlock, and then Aqua Security and Sysdig. So there's other ones that are out there to use for that. On the cloud security side, there's lots of cloud compliance or cloud misconfiguration vendors out there that can help you find vulnerabilities. The ones that I come across the most are going to be Palo Alto's Prisma Cloud, which was formerly Redlock. You've got Checkpoint Dome 9, which was formerly Dome 9 before Checkpoint acquired them. You've got Divi Cloud, which Rapid7 acquired recently. Now it's Insight CloudSec. And then you've got Lacework, and Wiz.io is one that's fairly new. And they are heavily focused on vulnerability management and doing agentless vulnerability discovery in your cloud environment, but also on the assets within your cloud environment.
David, we do have another question for Q&A.
Okay.
That question is, how do you manage the vulnerability feeds to confirm you are receiving the best information?
So here it's just comes back to what I was just saying before. Can we group this at a higher level than CVE and figure out what our biggest buckets are? What technologies, what software, what, if we're on the application side, what are the categories, the last top 10 categories that we're struggling with the most? And then start having conversations with your teams that are responsible for remediating those vulnerabilities and dig into, why are we having these issues? And then in terms of like confirming whether or not the tools are finding the things that they should be finding, or whether or not they're false positives or false negatives, that goes back to what I was talking about earlier, where it's going to be a manual effort at first, and we can maybe do some comparisons to what our manual testing teams are finding versus our automated tools. And for the vulnerabilities that our automated tools should be finding, why are our manual testers finding those? If it's business logic flaws, authentication, authorization bypass, we expect that. But if it's cross-site scripting, SQL injection, if it's some sort of patchable vulnerability that they're exploiting, why aren't our tools finding those? So a combination of manual analysis and then leveraging the other testing types that we have to figure out where our tools are falling short and how we can improve.
Okay, that is all the time we have for today. Thank you so much, David, for your great presentation. And thank you also to Arctic Wolf, Automox, BlackBerry, Cisco Umbrella, Extra Hop, Gigamon, Rapid7, and Vulcan Cyber for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.
All right, thanks everyone.